A nerve impulse is how a neuron sends information. It travels as an electrical signal along the neuron and usually as a chemical signal between neurons. That electrical signal is called an action potential. Neurons can do this because they separate electric charge. Inside and outside the cell are salty fluids full of ions. Sodium ions are mostly outside. Potassium ions are mostly inside. The membrane between them is an insulator with selective channels, so a voltage can exist across it. At rest, the inside of a neuron is negative compared to the outside, usually around minus 70 millivolts. This resting potential exists mainly because potassium leak channels let potassium drift out, leaving negative charge behind. Sodium mostly stays out. A sodium-potassium pump uses energy to maintain these gradients, but the leak channels create most of the voltage. Signals arrive at the dendrites and cell body as small voltage changes called graded potentials. Some make the membrane less negative, and some make it more negative. The neuron adds them up at the axon hillock. If the voltage reaches a threshold, an action potential starts. If it does not, nothing happens. Once threshold is reached, the action potential is all or nothing. Voltage-gated sodium channels open. Sodium rushes in, and the membrane rapidly depolarizes, briefly becoming positive. Then the sodium channels inactivate, and voltage-gated potassium channels open. Potassium flows out, repolarizing the membrane. Because potassium channels close slowly, the membrane overshoots and becomes briefly more negative than resting. After this, the neuron enters refractory periods. During the absolute refractory period, sodium channels cannot reopen, so another action potential is impossible. During the relative refractory period, firing is harder. This is why impulses move in one direction. The impulse travels along the axon because depolarization in one region triggers depolarization in the next. In unmyelinated axons, this happens continuously and is slow. In myelinated axons, the membrane is insulated by myelin, with gaps called nodes of Ranvier. Action potentials are regenerated only at the nodes, so the signal appears to jump. This saltatory conduction is much faster and more energy efficient. When the action potential reaches the axon terminal, electrical signaling usually ends. The depolarization opens voltage-gated calcium channels. Calcium enters and triggers vesicles to release neurotransmitter into the synaptic cleft. The neurotransmitter binds to receptors on the next cell and opens or closes ion channels, creating a new graded potential. So overall, nerve impulses travel as electrical action potentials along neurons, are regenerated as they go, move in one direction because of refractory periods, travel faster with myelin, and are passed to the next cell using chemicals at synapses.